our mesh. Choose for our UV, which define the part of the texture that matches with the three films that we need to see.
Everything up and running, clicking on the wrong buttons. They'll be a little bit more organized. Throw that in there, slap it in there. Damn. All right. Let's do this. Shout outs done. Let's go. Okay. Pick it back up. So yesterday I found out a few things. One, the reason why this was so dark looking was because you're making your materials. You gotta make sure you change your shader because I had it as default and or standard, right? So it's like taking into account. There's no lighting. So I went back. I was looking around. I was like, "What the heck? This should be easy." And then it was unlit, and then it was texture, and boom, there you go. Yeah, because if you're watching Code Monkey's video, it actually shows it, and it's like nice and bright. And I was like, "What? Why? Mine's nowhere near that." Oh, there you go. Anyways, all right, let's jump back into this and follow along. So I started a little bit here, and what he's doing essentially is building out his mesh.
Set. When need to set the vertices, which is an array of vector 3s. Vertices represent each vertex of our mesh. Then we also need to set the UV. This is an array of vector 2s, which define the part of the texture that matches with a certain vertex. And finally, we need to set the triangles, which is an array of ints, which define the vertex index, and 3 of them make up a polygon. Okay, so let's set them all up. First, let's make some local arrays. We're going to set them up, and only in the end do we assign it to our mesh. So we need an array of vector 3s for our vertices. Then we need an array of vector 2s for our UV.
There.
And finally, we need an array of ints for our triangles. Alright, so we do it, we set them all up, and finally we upload them to the mesh. Alright, so far so good. Now, as you can see, we need to define a size for our arrays. So let's start off with the simplest thing we can render, which is a single polygon. In order to create a triangle polygon, we need 3 points. So in here, we're going to have 3 vertices. Then the UV is always the same size as the vertices, so we also have 3. And finally, the triangles contains the indexes of each vertex that makes up a triangle. And a triangle is made up of 3 points, so in here, again, we're also going to have 3. Alright, so just like this, let's test and inspect our mesh. Okay, here we are, we still can't see anything, but let's inspect our mesh. And there it is, our mesh now has some data. It has
So he made a test mesh.
3 vertices, it has UV and 1 triangle, 1 polygon triangle. Alright, great. Back in the code. In here, let's define our vertices.
So that's all set up. Technically, I am doing something a bit much because you're not supposed to see this. I think it's, yeah, there. That's what I was supposed to do that. Won't show anything, but what it did is it created that. You see down here. 3 vertices, 1 triangle, and UV. Ah, cool deal. Following along, we got it, we got it.
So we're going to have 3 vertices. For vertex 0, let's put it on new vector 3 on 0, 0. Then for the 1, let's put it right above, so on 0, 100. And finally for the 3rd vertex, let's put it up and to the right, so we're going to set it to 100, 100. Alright, these are our 3 vertices. Now for the UV, let's ignore it for now. And finally for the triangles, this is an array of ints which contains the index of the vertices that make up a polygon. So let's start our triangle on vertex 0. Then we connect vertex 0 into the vertex on index 1. And finally we connect it into the index 2. And that's it. Now one thing that is very important in here is the order of the indexes. Each polygon has a face and a back face, and some shaders will call the back face. What defines the front and back of the polygon is the order of the indexes. In order to see the front face, always set the indexes in a clockwise order. So here you can see that our triangle is going from the origin, then going up, and then up and to the right. If we swapped it and did up to the right to the up to the down, then we would have set our triangle counterclockwise, which would swap the front and back. So always keep that in mind, and in most cases just set it to clockwise. Alright, so now that we've...
Yes. I'd have to actually see how that works, but alright.
Set everything up, let's test. Okay, here we are, and we still can't see anything. Let's inspect the mesh, and there you go, everything is correct. 3 vertices, triangles, and the UV. And the reason we can't see anything is, like we've seen previously, we need a mesh filter for the mesh, and then we need a mesh render. And yep, we can finally see our nice polygon. Awesome! If we inspect the scene, and again put it on wireframe, we can see our nice polygon.
Alright, so over here, test. Look at it. Oh. See 3 vertices, 1 triangle, and UV. right. So what he did, came over here, he added a render. And blam, there it is. Although it's off-centered, so should probably put that over there. But do that outside of play mode. So mesh render, we'll add that in there. Set this default to 0. Play. Boom. And it's in there. Now it's going off because the origin point 0, 0. So it goes up, I think 100. Yeah. So that's probably why it's doing that. Yeah. Cool deal. Let me see something real quick. Ah, camera, what are you doing? I don't want this to be relatively simple. I think it's because my screen. Yeah, my screen's too big. Guess I could scale this out some. Yeah, the negatives of this thing being too large. But anyways, yep, if it's there. Magic. Okay. Scale it down some so we can see. All right, cool. Got that going.
Polygon connecting, there's a vertex here, one here, and the triangle connecting all of them. Now our polygon is currently not displaying a texture because we did not set the UV. So let's do that. So we're going to set up the UV array. Now in here, the UV array always has the same size as the vertex array. So we have 3 vertices and 3 UVs. Each UV index contains the texture position that should be matched to the vertex in that exact same index. Over here on the project files, I have this texture. As you can see, it has a bunch of different colors, so we can easily see what part of our texture is being shown. Now we want to apply this texture to our polygon. In here, the UVs are vector 2s, and they are normalized vector 2s. That means that the lower left corner of the texture is on point 0, 0, and the upper right point is on 1, 1. So we created our polygon with 3 vertices, one on the bottom, then one above, and one to the right. So in order to display this texture, just like the polygon shape, we're going to set the vertex on index 0 into 0, 0, so that it displays the lower left corner. Then on the index 1, we want to show the upper left part of the texture, so we're going to keep the x at 0 and the y at 1. And finally on the 2, we want to show the upper right, so we set it into 1, 1. Alright, that should do it. We assigned our vertices, our UVs, and our triangles. So our mesh has complete information. Let's test. So here we are, and we still see the same pink texture. The reason is because we need to assign our material. So down here we have our texture. Let's make a material to apply to it. So a new material, call it the same thing. And here,
So what do I call mine? Heat map. All right.
in this case, let's use a very simple shader. So just unlit texture, and we drag our rainbow texture. Okay.
He explained it.
Just drag the material.
That's what I get.
And there it is. And as you can see, the texture perfectly matches with the corners we selected. So down here, the light blue, exactly matching that one. Then up here, the green, yep, and the red, yep. And the rest of the texture is not visible since we did not set the UV to use it. Awesome. So a triangle is a great shape, but a lot of the times a square shape is more helpful.
All right, so let me do this real quick. Try to get my camera correct. Nice. Although I will say, his comes out looking different. But it is what it is.
So let's see how we can expand our mesh in order to make a quad. Now here in our code,
He has a rainbow square. I think it's simply because the one I chose was Yeah, it only goes to that color range. Yeah, that's why. Okay. Cool deal.
Because we apply to it. So a new material, call it the same thing. Texture, let's make a material to apply. We need to assign our material.
Right.
So down here we have our texture. Let's make a material to apply to it. So a new material, call it the same thing. And here, in this case, let's use a very simple shader. So just unlit texture, and we drag our rainbow texture. Okay. Now back in our testing object, we just drag the material, and there it is. And as you can see, the texture perfectly matches with the corners we selected. So down here, the light blue, exactly matching that one. Then up here, the green, yep, and the red, yep. And the rest of the texture is not visible since we did not set the UV to use it. Awesome. So a triangle is a great shape, but a lot of the times a square shape is more helpful. So let's see how we can expand our mesh in order to make a quad. Now here in our code, we set up our triangle, which has 3 vertices, 3 UVs, and 3 triangles. Now in order to make a quad, essentially what we need is just another triangle. We put 2 triangles together and we have a nice square. So let's think about what we need. In order to make a square, we need 4 points, so in here we need 4 vertices. Then UVs are the exact same number as the vertices, so again, also 4. And now for the triangles. Over here we have 3 triangle indexes per each polygon. Now in order to make our square, we need 2 polygons, so that means we need to have 3 times 2 triangles, which is 6. And that's it, that's the size of our arrays. Now here we are setting up our values. So you have 0, 0, 0, 100, 100, 0. And in order to make a quad, what we need is the one that is right and down. So let's set the vertex on index 3 to be on 100 and 0. Now on the UV, let's show the entire texture. So for the UV3, let's put it on 1, 0. And now in here for the triangles, the first polygon stays the same, so we'll leave the first 3 indexes. And now for the next 3, again, remember to set them clockwise. So for the second polygon, we're going to go from vertex 0, then go into vertex 2, which is up and to the right, and finally go into vertex 3, which is to the right and down. And that's it. We have our quad nicely set up. So we have 4.
Let's catch up a bit. So you start the origin and go the other direction. Okay, I see. Let's grab this. Oh, I'm still yawning. He moved his stuff around. That plays a role here. His UVs are different. It's odd. He moved it and I didn't realize it.
Vertices for UVs and 6 triangles. Alright, let's test. And yep, there it is. We have our quad being displayed as a perfect square showing the entirety of our texture. So we have essentially recreated the underlying code for the sprite render. If we inspect our scene, we can see that indeed we have our 2 polygons. So we can see shaded wireframe and see exactly like that. We have 2 triangles connected in order to make a nice quad. So now you know how to create a mesh and set up the vertices, UVs, and triangles to take any shape you want. Every other effect you want to make is just an expansion of this code by adding more vertices and different triangles. For example, let's make some tiles.
Watch him build this out, see what's up.
Alright, so here's the code to make some tiles. Now I plan on doing a dedicated video on how to make a grid map and visualize it, but for now I just wanted to quickly demonstrate the various uses for the dynamic mesh. So in here you can see that I have a certain width and certain height. Let's put this bigger, let's put it 4x4, and a certain tile size. Then the vertices, I calculate them by 4, since again we have 4 per quad, so 4 vertices, 4 and 6. Multiply them by the total size of the grid. Then I cycle through the width, cycle through the height, and set the quad data for that specific quad. So do all of this, and then the result. And here it is, we have our result, our nice tile grid. So again, the way that it works, essentially each of these is a nice quad. So we can go back into the scene, and here inspect, and you can see that each of them is indeed one quad.
Legit.
So this is just an expansion of what we were doing previously. So instead of having this texture, you would add a floor tile texture, and you can see how you could have a nice floor tile system just like the one that is used in Battle Royale Tycoon. Now for another example, let's make a simple animation.
That'd be interesting. Oh, I think I see what he's doing.
Alright, so here is a small animation that functions exactly like the custom animation system that I use in my videos. So as you can see, the head is bouncing up and down, there's a body behind it. And if we go and inspect again our wireframe, there it is, you can see the quad for the body and the quad for the head. So put it on shaded, and yep, there you go. You can easily see 2 quads and one of them is moving. And down here I have the texture. And as you can see, it is a simple sprite sheet texture with the various body parts cleanly separated. Now here in the code, as you can see, it is all based on quads. So we have 2 quads, then we have a quad to render our body, exactly the same way that we created our previous quads, and another one for the head. One of the main differences is over here on the UV. Again, the UV is a normalized value, so we need to take the texture width and height in pixels, take the position in pixels, and then we simply divide them in order to get our normalized values. So we do that in order to just show the body texture on this first quad, and down here we show just the head texture. And then down here, I'm using the CodeMonkey utilities to create the function on update, so this code runs on every update, and it's just a simple moving up and down code. So as you can see, I just take the head position, I move the Y up and down, then I modify the vertices array based on the new head position, and I upload them back into the mesh. Remember that in order to modify a mesh, first you need to modify a local array, and in the end you need to apply it to the mesh. So we do all of that, and again, here is our nice result. We have our simple character with 2 quads, one of them moving up and down by modifying the vertices. And again, you can see that it is all running on a single game object on a single mesh. So this is the core for my animation system. You just add more body parts, store the keyframes positions in a file, and have it all working. So now you know everything you need to know about making custom meshes. Now go ahead and make some cool stuff yourself. As always, you can download the project files and utilities from unitycodemonkey.com. If you like the video, subscribe to the channel for more Unity tutorials.
That's pretty cool. One of the things I kind of want to do is, so what was it? Thomas Brush has a pretty cool tutorial on how to make animations with the built-in, I think it's called spine in Unity. If I could figure out how to combine that with pixels, not make it look too jank, I could probably make some cool stuff that way. We'll see. All right. So that, I guess, concludes the dynamic mesh portion of what we're doing. Now we did all that to actually get into the to prepare for the heat map. Heat maps. As of right now, what we got? We got powerful generics is what we have next, followed by pathfinding, which is fun. I did that. Took me a while. Finally got that working, and then after that is the heat map. So I guess I jumped the gun a bit, question mark, but we'll see. Now go ahead and get into it.
Object. Another type is just using a simple boolean. So as you can see, everything is false, and when I click, it turns into true. And I've also modified the heat map visual in order to work with the generic with boolean. So as I click, it turns from black to
A little
green.
confused on his ordering
so
of
with
this.
generics, we can set up our grid to work with whatever type we want. That means simple types like in.
I do feel like, let me take a look at the heat map one. It's fourth on the list, but it does seem like that's kind of the one that would follow after making your original grid. We'll see. Let's check it out.
We have a nice scene here, and it looks like it's completely empty and just with a black texture. However, when I click on the mouse, yep, there it is, I placed something which modified the underlying grid and the visual display. So I can click with the mouse button in order to impact the underlying grid, which then impacts the visual, and as you can see, the visual where it's clicked, it's red, and as it gets towards the edges, it becomes red, and where the value is 0, it becomes black. So the color is smoothly interpolated based on whatever value is underneath. Now I have enabled debug visual, so we can see the underlying shape and values of the grid, and you can see that when I click, the values change and the visual also changes. So right down the middle, you can see that it has 100, which is the maximum value, and as it gets towards the edges, it continually goes down until it reaches 0. An example of something like this used in a complete game is the park environment system in Battle Royale Tycoon. In the game, you can place objects to improve the park environment, and each of them has a radius and an effect they cause. So when I place an object, the environment updates and increases the underlying value in a nice timed pattern. So this is an example of a system like this being used in a final game. Alright, so this is our goal. Let's get to it. Okay, so here we are in our scene.
Yeah, okay. This seems more logical. I mean, I'm pretty sure the other one would be fine just to use that and then eventually get here, but I'll do this first. So this is dynamic mesh. So let's say dynamic mesh package. Cool. Nice. All right, so that's done. Let me package this up. You know, guess I don't really need that. uh, you know what? I think I would put testing scripts. Lol. Just take that and toss it in there. Yeah, sure. This is. I guess this will be our generic grid one. Yeah, sure. Okay. And let's hop back over. I keep losing track of things. Ah, okay. Alright, cool.
Where we have just a simple background texture. Also in here on the scripts folder, I have the grid class that we created in the previous grid map video. If you haven't seen that one yet, there's a link in the description. In that video, we go through the creation of the grid class, which we are now going to use as a base to create our heat map. The grid class is already based on ints, which is exactly what we want to use here, so making this effect should be relatively simple. So let's first start off by making sure our grid class works. So we're going to create a new script, let's call it testing. And here, make a new game object, call it testing, and drag the script onto it. Okay. Now in here, let's make a private void start, and in here, let's create a grid. So we do grid, make a new grid, pass in the width and the height. So let's pass in width of 20, height of 10. Now we pass in the cell size, let's say 10, and the origin, let's put it at vector 3.0. Alright, so let's see what this does.
Alright, so go ahead and this. Trying to think, should I modify this? No, I have an idea. I'll just change this. I'll say grid testing. Come back out here, change this. I know it's gonna break things. Grid testing. There you go. Take it, slap it back in there. Close that out. We're gonna create a new script here. That way we can follow along and actually, I guess, review the tutorial. Follow it by detail testing. Thank you for constantly opening that, not doing anything. Okay. We're gonna say grid equals grid 20 10 10f vector 3. That's definitely not vector 3. Dot 0. All right. I really need to make a background that doesn't look like this. Like, I hate the way this looks. It's so plain compared to everything else. You know, we're testing functionality, so I guess looks don't matter. Maybe at the end, we'll go through and actually make like a not boring background, huh? Like, oh my god. I am subscribed to, what's their face? You know what? Take a 5-minute breather. Pace. Where we at? Pixelcraft? Is that what it was called? Craftpix.net. Yeah, there it is. Why am I not signed in? Odd. Wow, this thing takes a long time to authenticate. Sure. Anyways, sorry about that. Yeah, no, for those interested in pixel shenanigans, definitely here. This place is great. You pay a subscription fee, right? And yeah, it's pretty much legit. You can download all kinds of game kits, 2D, etc., etc. It's pretty damn good. What else I do want? Oh, there is a spider crawling on my wall. Oh Lord, help me! Oh, that's bad news, bears. I'll be right back as I get rid of this demon attacking me. Ugh, crisis averted. I was just sitting there and the spider just shoots up the wall. I was like, ha. Ha ha ha. Anyways, let's check it. Do kind of want to top down. Let's see. Tile sets. A lot of these are 2D platformer, but map pack. Interesting, they don't have more top downs. But I am making somewhat of a platformer, so it is good for me. Screw it, why not? We'll get that. Download, please. All right. Let's see. Excuse me. Let's see. Put that with the rest of them in my pixel practice. Again, I have too many things in too many places. But oh. Wow, they actually don't have a pre-built stage for you to play with. Well, looks like we're gonna use this to learn about tile sets when the time comes. It is pretty neat looking. Look at all these things. Little tiny baby trees. So we'll get to that when the time comes, but we at least have it now, right? Okay, so let's pick back up.
And here we are, and yep, there it is, our full grid map with a width of 20 and a height of 10. Alright, awesome. We have text objects being created which show the underlying values, and using gizmos we are enabling to show the edges of each grid cell. Again, all of this was fully created from scratch in a previous video, so check that out if you haven't already. Alright, now that we can see our starting grid, let's think about what we're going to need in order to make our heat map. The first thing we want is to make sure our grid's underlying values stay inside a valid range. So let's go into our grid class. Here it is. Now we have our simple constructor, which as you can see we receive width, height, a cell size, and a origin position. Then over here we have the code to show our debug lines and text fields. And if we go all the way down here, we have our nice set value function. So it's here that we want to validate this value to make sure it stays within our valid range. So for that, let's make some constants. Go all the way up here, make a public const int, and let's call this the heat map max value.
So in here, it's making a public
let's put a maximum of 100 and a public constant for our heat map min value, which will be at 0. And now we just take these and go down to the set value, and let's make sure that our value is mathf.clamp. So we're going to clamp our value between our minimum and our maximum. Alright, that
I'm not familiar with this. I don't know what language this refers to, but... where did we put that in our set value area? So in our set value, he does... hold the phone. Interesting. Some of his stuff has changed. Grid value does not equal null. Grid has changed. Perhaps I should follow his structure. There are things in here that are slightly different. The logical order to this stuff is starting to confuse me. In here he has heat map visuals, he has all that information already in there. We'll go ahead and go with this and pretend everything's going to work as intended. See what happens.
that should do it.
So, anyways, public void. So we're going to say not doing value anymore. We're going to say mathf.clamp. Say the value is going to be between heat map min and heat map max.
Good. So let's go back into our testing script. And in here, let's make some code to increase the underlying value on the grid whenever we click on it. So we make a simple update. In here, we test for an input, get mouse button down on the left mouse button. And when you do, let's get the mouse world position. So for that, I'm going to be using the CodeMonkey utilities, which as always you can grab for free from unitycodemonkey.com. So from that, I can use get mouse world position. Here is the function in case you want to make it yourself. All it does is a screen to world point on our world camera. So with our mouse world position, we want to increase the underlying value of the grid. So before we set the value, let's first go in the grid and get the value. So in here, we need a reference to our grid object. So we have our reference, we set it on start. In here, we use it. So we get the value, pass in the...
Since before, I didn't set an actual... Sorry. Wake the fuck out when I did that. Value utils. Oh. Why? Using pasted. utility class. And like you said, he offers his utility class for free. You can download it from his site. It is awesome. Let me get that for you. Lol. Code Monkey. Where's his site? I don't have it in my history. Heresy. There you go. Come here, you can download the utilities. Grab it from there if you want. It is a bit, I will say, if you grab the utilities like that, it is made for him, obviously, and it is set up in such a way that it won't exactly be how you see it in this tutorial, in this video. It'll be set up like as a final form after he's like upgraded it and updated it for everything he's done. However, if you can pick it apart and organize it properly, you can get it to where it's exactly like what's used in this video. But yeah, that's why I'm building it piecewise over time.
All right. So this is our current value. Then we do grid.setValue, pass in the same position. And then we pass in value plus 5. So every time we click, we should be able to see the underlying value increase by 5. All right, let's test.
Oh, he created a thing. So vector 3 position equals utility class dot get mouse world position. Wait. And then we just change this to position. Wait, we just made that though. Come down here, set value. I see. Because that you need actual vector 3. Value plus 5. Yes. Cool.
Okay, here we are in our grid. Now, first of all, if we click outside the grid, you can see that nothing happens. In the previous video, we decided it was best to ignore invalid values in order to prevent our grid from behaving weirdly over on the edges. So if I click here, it does nothing, but if I click on top of the grid, there you go, that one went from 0 to 5, click again, 10, and now keep clicking, and let's see the maximum, and there you go, it's at 100 and can no longer go higher. Okay, awesome. Alright, so now that the underlying values are working correctly, let's see how we're going to display them with some very nice colors. So that means it's time to work on our heat map visual. So in here, let's start off by making a new C# script, call it heat map visual. Let's make a game object to handle it. So a new game object, call it the heat map visual. Drag the script onto it, and let's make sure the object is on the origin. So 0, 0, 0. Okay. Now let's open it. And now in here, in order to display our heat map, we're going to use a custom dynamic mesh. If you want a in-depth look into how to create a...
What did you do?
Okay. Now let's open it. And now...
Oh, created a empty mesh or empty game object. And visual. That bad boy. Ah, I clicked on something else.
Outside the grid, you can see that nothing happens. In the previous video, we decided it was best to ignore invalid values in order to prevent our grid from behaving weirdly over on the edges. So if I click here, it doesn't end, can call it heat map visual. Let's make a game object to handle it. So a new game object, call it the heat map visual. Drag the script onto it, and let's make sure the object is on the origin. So 0, 0, 0. Okay. Now let's open it. And now in here, in order to display our heat map, we're going to use a custom dynamic mesh. If you want a in-depth look into how to create a dynamic mesh through code, then check the link in the description. In that video, I cover what are the elements a mesh needs and what each of them represents. It covers how to start off rendering a simple triangle, then making it into a quad and manipulating the texture. If you understand everything in that video, you'll be able to easily follow along how we're going to create the heat map visual mesh. Okay, so let's create the mesh. And for that, I have a simple mesh utils class. This has a bunch of functions for creating and adding stuff to the mesh. You can easily make this class yourself based on the knowledge of the mesh video, or you can download it from this video's project files.
Uh-oh.
It just creates the various vertices, UVs, triangles, and has a bunch of functions for setting them.
Sure. Well, I thought we would just be using what we made before, but this looks a bit more intense. Ah, damn.
Again, if you're not familiar with how mesh is created through code, check out the other video linked in the description. Now, in order to render our mesh, there's still something we need on our game object in here, which is we need to add a mesh filter and also a mesh renderer. So this mesh...
I mean, I get that, but goddamn, dude. That util looks intense. Oh, man. Hold on. I could at least do this. Mesh filter. Mesh render. Might have to go download that. I'm going to follow along because that was pretty intense looking. Not going to lie. Let's see. Try downloading these files. I was logged in. Oh. Oh, okay, hold on. Yeah, I gotta go over here and get this thing downloaded. I do have these utilities already. Let's see. Assets, grids, scripts, utility, mesh. Let's bring that up. Like, I understand some of this. Creative mesh, rotations, all that jazz. I guess for the sake of it, we'll just add this to our file, our folder. Project. There you go. So this isn't actually a part of...
to trigger the event. Then when something changes inside our object, we're going to...
Wait, that's a generic... Whoops, wrong.
A mesh created through code has a bunch of functions for setting them. Again, if you're not familiar with how mesh is created through code, check out the other video linked in the description. Now, in order to render...
Okay, so he has his quad count. Okay, his vertices. Okay, his UVs. So I understand how he makes that. So essentially, he creates an empty mesh. This is fine. It's just a simple mesh. Then he has classes that will called a quantity that he wants to create. So it creates an array of empty meshes. And then depending on what you give in, okay, yeah, I get it. Huh. Interesting. All right, let's go ahead and do this. So I'm going to pull over mesh util, put it in scripts. It's going to bring it up. So this is his. I'll leave his credits to him. All right.
Under our mesh, there's still something we need on our game object in here, which is we need to add a mesh filter and also a mesh render. So this mesh will be created dynamically through code. And now in here, we need to add our material. So here in the project files, you can see that I have a nice gradient texture. As you can see, the first pixel is black, then it goes from red to yellow to green. So let's make a material to use it, just very simple. Make a new material. Let's use the unlit texture and drag the texture onto it. Alright, there's our material and just drag it onto our mesh render. Alright, that's it. Now back in the code. Now here, in order to visualize our heat map, we want to display one quad per grid position. So first, we need a reference to our grid, so let's make a function, a public void, call it setGrid, and we're going to receive a grid object. Let's store it. Alright, so now we need to call this function from somewhere, so for that let's use our testing class. And here let's add a serialized field, make it a private of type heatMapVisual. And on start, first we create our grid, and then we go into the heatMapVisual and set the grid and pass in our grid. Alright, so now we just need to go into the editor, and here on the testing script, let's just drag the reference. Alright, awesome. So back into the heat map code, let's also make a wait.
Up. This grid equals grid. Nice. Close that.
To grab the reference to the mesh filter. So we have the reference to the mesh filter and we need to set our mesh. So in here, let's make a mesh equals a new mesh. So this is the mesh that we're going to use and reuse.
Private void.
So let's actually store it up here. Just like that. Alright. So all our setup is done in order to visually see our mesh. Now it's time to finally make the code in order to actually draw it. So down here, let's make a private void and let's call it update the heat map visual. Now in here, let's...
What? Okay, hold on. Oh, that was in his testing, wasn't it? Shite. I think so. Hold on. Yeah, he was updating.
Make a wake to
he was updating the testing field. I accidentally did that somewhere else. Oh, what's up, dog? What's up, dog? What's wrong, huh? Old dog's back. What's wrong? Good girl. Alright. Probably have to take her out soon. I'll do that at 10, so we got 15 minutes roughly. Anyways, yeah, so he was doing that in testing. I was throwing that into my heat map visual. So let's get that, pull them out, put that there. And then his start, he has his grid he generates, then he does a heat map visual dot set grid. Legit. Then I have to come back over here. I have to do this properly. So it's private can't spell private. Mesh. Change that. Mesh. Don't know why that's capitalized.
So now we just need to go into the editor, and here on the testing script, let's just drag the reference. All right, awesome.
Comes over here, testing script. Put that there. Dunzo. Oh, dog, I need to give you a bath.
So back into the heat map
I
code.
smell you.
Let's also make a wake to grab the reference to the mesh filter. So we have the reference to the mesh filter, and we need to set our mesh. So in here, let's make a mesh equals a new mesh. So this is the mesh that we're going to use and reuse. So let's actually store it up here. Just like that. All right. So all our setup is done in order to visually see our mesh. Now it's time to finally make the code in order to actually draw it. So down here, let's make a private void, and let's call it update the heat map visual. Now in here, let's first set up our arrays. Here on the mesh utils, I have a nice function which already calculates all of the vertices, UVs, and triangles with a given quad count. So let's use that. So go into the mesh utils, call create empty mesh arrays. Now for the quad count, it's very simple. We just need the grid in order to get the width multiplied by the grid.getHeight. So that's our quad count, and now let's create our arrays.
Wait a second here. Something wrong here.
Alright, so just like this, we are creating all of our local arrays with the correct size. Now down here, let's cycle through the width and the height. Alright, here we are inside our cycle, and now in here, let's first calculate the index that we are currently on.
Stop. Okay, something's up. I don't have... That's odd. I'm missing the functions get height, get width. Is that coming from here? I think so. I wonder if I have an outdated version of this script. That's interesting. Let's take a gander here. Let me double check that.
Hello and
Shouted at me. Apparently this one has the correct mesh utils. As soon as it finishes loading. Oh god, I don't want to download everything. Ah. See, we only want to grab one thing from here. It's in here. Jesus, this man knows how to build. Odd, I thought it'd be in here. Where's your mesh utils? Oh boy, there's a lot to go through. Oh Lord. Jesus Christ. There's the mesh particles. Oh, there it is. Holy crap. I'm surprised I found that. I want to download anything else. Just that. Alright, so close that. No. None of that. Okay. Alright. Hopefully I'm only getting that. Fingers crossed. Uh-oh. And then everything broke. Wait a second. This doesn't look any different. Am I jumping the gun again? Huh. Perhaps I am. Tell you what, we'll back out of that. Message cannot be deleted. Okay. Yeah, I know. Oh, I'm an idiot. Oh. Don't look, everybody. Don't look. Oh boy. It wasn't coming from the mesh util, it was coming from the grid. Ugh. It's supposed to be in here. Assume it's just something along the lines of public int get width vector, I don't know, 2. I mean, my width is simply that. It's just my width. Honestly, I have no idea, but you know what? I'm just gonna call it. I understand though. It should just be that. So my grid should just return that. I feel like that's wrong. I feel like I'm wrong. Let's take a look at this. Yep. So it's just that. Okay. And well, that's how this works. I guess. Sometimes it's as simple as it seems. All right. So close that. This should be not throwing any errors now.
So in for our index, and the current index will be the current x multiplied by the grid.getHeight and plus the current y. So with this, we have our index cycling through every single quad. So let's just do a debug.log to make.
So the reason we need that so we can do get width x plus plus. Do this another. So we're gonna cycle through everything.
Make sure everything is great so far. So debug.log on our index. And in here, when we set the grid, let's call update the heat map visual. And to make it easier, let's go in here and reduce the size to be just 10.5. All right, let's test.
Yeah. Smaller grids. Huzzah.
And here we are, and there's our smaller grid, and over here on the console we can see our indexes are indeed going correctly. So going from 0 all the way to 49, since we have 10 by 5. Alright, awesome. Now in here inside our cycle, we already have the index, and it's in here that we need to set our quad values. So for that I have a very nice helpful function here.
Oh, it didn't print out our index. That's interesting. Wait, did I botch that by not paying attention again? Index equals x times grid.height plus y.
set the grid, let's call update the heat map visual.
Yep. Can't get anything if you never call it, right?
To make it easier, let's go in here and reduce the size to be just 10.5. Alright, let's test. And here we are, and there's our smaller grid, and over here on the console we can see our indexes are indeed going correctly. So going from 0 all the way to 49, since we have 10 by 5. Alright, awesome. Now in here inside our cycle, we already have the index, and it's in here that we need to set our quad values. So for that I have a very nice helpful function here. It's called add to mesh arrays, and just takes the various arrays that make up the mesh, takes an index and locates the new quad. So let's use that. Call add to mesh arrays. Let's pass in the vertices, the UVs, and the triangles. Now for the index, pass in our calculated index. And now here we need the position. So for the position, we can just go to the grid and ask for the get world position of this given X and Y. Alright. For the rotation, we don't want any rotation, so let's leave it at 0. And now here we need the size of the quad, so let's calculate it up here. A vector 3 for the quad size.
Wait, what? Oh. Another thing that's different. Interesting. Our grids are very different. Wondering when he updated these. I mean, it kind of makes sense, but still, it's a little. Huh. Wait, I have it in mind. Get world position. Why isn't it? Avoid this grid grid. Private. I wonder if it's because. Hold on a second. Let's try and fix this. What the heck? That's why. It's private. It's like, what the heck? It's right here. Why? 0F.
And the quad size is really just, let's make it a vector 3 of 1, 1 and multiply it by the grid and get the cell size. Right? Just like that. And now finally we need the UV, and for now let's just leave it at 0, so all our quads should be completely black.
Cell size. Did you just turn all these into publics? I don't even actually have that one. Let me bring these up. World position. Put that right here. Yeah. That's interesting. here he has 0f quad size vector 2 dot z. It's gonna be 0 and then vector 2 dot 0.
Over here on awake, we are creating our mesh. Then on this function, we are creating the empty mesh arrays with a given width and height. Then we cycle through every single grid position, and we add a quad to our mesh arrays. So all that's left is to go down here and update our mesh. Alright, that should do it. Let's test and see if we are correctly creating our...
So, just updating the mesh with the UVs, vertices, triangles.
our black mesh. And yep, there it is, there's our grid mesh. We can pause in order to go and look into the wireframe, and let's hide the background so we can easily see it. And yep, there you go, there it is. We can easily see every quad of our grid mesh being instantiated. Awesome. However, you can also see an issue with the mesh. The quads are on the origin of each cell position instead of being right down the middle. So we need to shift them all by half of our cell size. So let's do that. It's very simple, just in here we get the quad position and we just increase it by the quad size multiplied by 0.5.
Yeah, it is off-centered, and I can't see this because my background is black. So let's change that to something that's not black, like, I don't know what it is by default. Weird light blue. Whatever. That works. Alright, actually that's gonna go away as soon as I do that. But if there's a way to set this back to default. Reset. There we go. Oh, I lost my stuff. Oh Lord, I have no idea what's happening. I can't see anything. Great. You break things. Huzzah. Screw it. That's fine. Alright, but grid is off-centered like you said, so here. We're putting it back at the original position. We said, or not there. Sorry, this gets world position, which is 0, 0. But we need to get it to line up with our grid, so it's gonna have to be times quad size. Yeah, it is times quad size. Plus quad size. Sorry. Plus quad size times quad size is this. Our vector is at 1, 1. I'm the excuse me. Grid cell size. Right. Cell size is okay, cool. Over here we play it.
Okay, test again. And yep, there it is, and all of our quads now perfectly match with our underlying grid. Great. Okay, so now the visual is set up. However, if I click to modify it, you can see the underlying value changed, but the color didn't. So we need to update our visual when something changes. So over here in the grid code, you can see that right in here there's a nice event. And as the name implies, this is fired right when some value on the grid changes. So there it is down here on the set value. You can see we set the value and then we fire this event. So we can easily go back into our visual, and when we receive the grid, let's simply subscribe to that event. So grid on grid value changed. Let's subscribe to that event.
Wait a second. I don't have that. I need to figure out. Where did he add these at? What video did he add these in? What if he was working on these simultaneously and just forgot? Anyways, so over here he says what? I'm gonna just comment that out for now. If on grid value change. See, this makes me think like in the other one, in the generics, he references the heat map. But in the heat map, he references the generics. And it's just like, wait, which one did you do first? But it's fine. We're gonna go through both of them, so we'll see what went down. Grid. Yeah, so I'm gonna bring up the not cool, dude. Sorry, someone's kind of breaking the rules a bit. My game dev chat. I understand people want to do this, but the community channel I'll put in there. Sorry about that. All right, let's see here. Oh, I was supposed to take her out. Oh, I was supposed to take her out. Alright, I guess I'll have to call it here because my dog is like laying down under my feet, staring at me like, why? Why have you done this? Alright. We're going up. In position, yeah. Where is this found? Event handler. Yeah, I haven't even. I'm pretty sure this comes from the generics video. I feel like those two just really go hand in hand. Either that or he had a previous video where he did that. Like they were both one or something. I don't know, but this is rather important. Yeah. So, I know, pup. I know. I'm coming. Public event handler. Great. It's supposed to be using system, correct? Yeah, there you go. All right, so he has that, which enables him to have his on-grid. Whew. This is gonna be fun to recreate when we go over to the other one. I'll probably just after I'm done with this. Let's see, another 14 minutes on this video. Let's see, on-grid value changed. This, I know, Yuki. Grid value changed event args. X equals X, Y equals Y. Let's change. Yes. I changed that. Type it wrong. Alright, cool. Okay, well, I have to go for now. When I come back, I will come back. I'm gonna work on this a little bit longer. So lunch, I think. All right, pup. All right. I don't know how long I'll be gone, so then I will be shutting down the stream and I'll bring it back up. Anyways,